Trust me when I tell you that everything that you need to solve any question about binomial expansion or binomial series are these formulas that you have here on the MF19. Now, if you look at this the way they are, chances are that you won't understand what this means. So the purpose of this lesson is to give you the basis from which these formulas are going to be derived, but this alone won't enable you to solve the questions. In order for you to solve these questions, once you know what this means, and that is the purpose of this lesson, but for you to solve the questions, you need to practice with examples. And then our next lessons are going to be very important, the ones in which I will introduce first simple questions about binomial series, and then getting more and more complex until you'll find exam style questions and actually exam questions. So again, this is all that you need. This is going to be with you in the exam. This should always be with you when you are practicing with exercises and problems. You won't understand this if this is the first time that you are looking at this. So our lesson today, the one that I'm going to bring in 1 minute, is to explain what this is and where this comes from. But the actual knowledge that you are going to build to answer questions will come from solving exercises. Okay, so you have all these steps to follow in order to solve all these questions. Once you get used to it, I can guarantee that this topic is not hard at all. It just seems because this kind of looks weird, but the chapter itself is not complicated. So let's get started with the lesson. And I'm going to start with this. Let's say that you have this expression over here, x plus y, the whole thing to the power of 0. How much is that? Well, that's simple. Anything to the power of 0 is just 1. What if you have x plus y now to the power of 1? That's simple as well. Okay, that's just x plus y. But for the purpose of what I want to go, I'm going to put here the coefficients and the powers. So the coefficient is 1 and the power is 1. Okay? What if I have x plus y squared? Well, x plus y, the whole thing squared, is x plus y times x plus y. You already know how to expand that. So you'll have x squared, or 1x squared, plus 2xy, or 2x to the power of 1, y to the power of 1, plus y squared, or just 1y squared. Again, I'm writing down the coefficients because I want you to see later on a pattern. If I have now x plus y to the power of 3, that's x plus y times x plus y squared. X plus y squared, we already know what it is. Okay, so we can cross multiply. I have here already the end result, and that is 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Continuing, x plus y to the power of 4. The result is going to be 1x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus 1y to the power of 4. Why did I bother to do this? I don't know if you are getting the pattern, particularly on what's happening to the powers of x and y as you go from left to the right. Let's take this last one. First term, what is the power of x? Is 4. Second term, what is the power of x? Is 3. Third term, power of x is 2. Fourth term, power of x is 1. And fifth term, the power of x is 0. I didn't even bother to write it down. X, the power of 0 is 1. But the power is actually 0. The opposite happens to the y's. Over here, you have y to the power of 0. Again, I didn't bother to write it. This is y to the power of 1, y squared, y cubed, y to the power of 4. So, right now, would you be able to write down what is the expression that you'd get if you have x plus y to the power of 5? At least in what regards the powers of the x's and the y's. Okay, yes, the x, the first term would be x to the power of 5, x squared, sorry, x to the power of 5, x to the power of 4, x cubed, x squared, x to the power of 1, x to the power of 0. Then for the y's, on the first term, you would have y to the power of 0, y to the power of 1, y squared, y cubed, y to the power of 4, y to the power of 5. Okay? So this is the pattern. The powers of the x's go down as you go from left to right, decrease. The powers of the y's increase, ascending powers of y, as you go from left to right. Now, the problem is the pattern that you have here with the coefficients. That is a little bit trickier. So everything that is coming now is for you to understand how these coefficients will be determined. Again, the powers of x and y are already explained. Everything else is to figure out what these coefficients here in pink can be calculated. All right? So, what do I have over here? I have here in each line the power. Okay? I'm using the same color scheme as I used over there. And then, what do I have here? I have here the coefficients that I wrote down over here in pink. Okay? So, for when n is 0, the coefficient is 1. When n is 1, the coefficients are 1, 1. When n is 2, the coefficients are 1, 2, 1. And 3, the coefficients are 1, 3, 3, 1. 1, 3, 3, 1. Then 1, 4, 6, 4, 1. If you had now the power of 5, what would the coefficients be? We already saw what the powers of x and y would be. Now, what would the coefficients be? If you look at the structure of this triangle, you probably get it right. You know that on the edges of this triangle, you will always have 1 and 1. What about these numbers over here? These come, every number over here is, if you pay attention, the outcome of adding the two numbers that you have on top left and top right. So, for example, this 3 is 1 plus 2. This 6 is 3 plus 3. This 4 is 3 plus 1. So, what is the value that you will put over there? Is 4 plus 1 is 5. Over here, you have 10 because that's 4 plus 6. Over here, 10 again, 6 plus 4. 4 plus 1, 5, and here is still the 1. Okay? If you look at this, you'll have a pattern in which the values that you have, they are symmetrical over here. So you have 10, 10, 5, 5, 3, 3, 4, 4, etc. Okay? And each result is the outcome of adding the two numbers that are on top left and top right. This is called the Pascal triangle. So now that you know these numbers, these correspond to these coefficients over here. So what would be the actual result of having x plus y to the power of 4? Well, the coefficients are here. For the first term, it would be 1 x to the power of 5, y to the power of 0, which I didn't write. The second term would be 5 x to the power of 4. It went down by 1. And the y, the power of y, goes up by 1. So I to the power of 1, or just y. The third term would be 10 x to the power of 3, went down. Y to the power of 2 went up. Then 10 again, x to the power of 2, it went down the x, and y to the power of 3, it went up. 5x to the power of 1, or just x, y to the power of 4, plus 5, plus 10, 10, 10, I made a mistake. This is not 5, this is just 1. X to the power of 0, and y to the power of 5. I need to make a correction there. Once you download it, you won't have that mistake there. All right? This is all fine. If you go to powers up until 5, what if you have n 10 or 15 or whatever bigger number? Then it would be very troublesome to make a huge Pascal triangle to figure out the coefficients, right? So a new method must be found. So I'm going to make a pause to bring up a specific type of number that is called a factorial that you need to understand in order to figure out the shortest way to get to these coefficients. So what is a factorial? A factorial is basically a number that is the outcome of multiplying this number by its next number. That is easier explained with an example than actually told. For example, 4 factorial is just the outcome of multiplying 4 by 3 by 2 by 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, which is, by the way, the same as 7 times 6 times 5 times 4 factorial. From this moment onwards, this part over here, it is just the 4 factorial, right? By definition, the factorial of 0 is 1. You need to know that. And x, whatever x is, factorial is x times x minus 1 times x minus 2 times x minus 3 times etc. until 1, until times 1. Okay? So factorials are these numbers. What are these going to be used for? We're going to see in a bit. Let's go back to the Pascal triangle. The information that you have here in a Pascal triangle can be represented not as a triangle, but as in a table in which you have in columns the value of n and in rows the value of r. Okay? So n and r. What is r? R is measured like this. Okay? This is r equals 0. It corresponds to this value over here. The coefficient of the first term always 1, 1, 1, 1, 1, etc. Then r equals 1 corresponds to the coefficient of the second term. So 1, 2, 3, 4. R equals 3 corresponds to the next one. So 1, 3, 6, etc. 1, 3, 6, and then eventually 10. It's measured like this, okay? I highlighted this in pink here in this Pascal triangle. So on this table, I have on the vertical columns the n's and our horizontal rows the values of r. And then I just plugged in this table the corresponding values that I had in the triangle, in the Pascal triangle. If you want to bother to check this against the triangle, you are free to do that. That's just the information that I had in the triangle. And what is the advantage of this? Is that you can retrieve each one of these values using this notation, nr. For example, what is the value corresponding to the 2, 1, in which n is 2 and r is 1? So n2, r1, that's 2. n4, r2, n4, r2, that's 6. n5, r3, n5, r3, it's 10. See, this table simplifies the process of finding these numbers. But again, it's still a table that you don't have access to in an exam. So what do you have access to? You will have access to this formula over here, okay? This is the notation that I used before, which, by the way, is called combinations NR. If you are taking statistics 1, I don't know if you reached this part already, but chances are that you did. You already studied this, combinations and permutations. This is exactly the same thing, okay? The process to find these numbers is exactly the same. Actually, you have here the definition of what this is, which is based in statistics. This gives us a number of different combinations of R elements chosen from a group of n distinct objects. You don't need to know this at all for the purpose of pure math, but this is what it means in terms of statistics. What you may be asked to calculate is the value corresponding to this combination over here. But for that, you have the formula, this one, which is also part of the MF 19, okay? So let's say that you want to calculate this value. Just substitute n by 5 and r by 3, okay? And you'll get the result. You have here the examples. Okay, I have more than you have 3, and the one I was using is this one over here. So 5 factorial, This is where you are using factorials. 5 factorial divided by r, which is 3 factorial, times n minus r, which is 5 minus 3 factorial. So this is the result. If you plug this in a calculator in one go, you will eventually have the value 10. But if you are using a calculator, then the calculator will tell you immediately what the value of the combination is. Let me try to put this in front of you with the light. It will depend from calculator to calculator. On this one, which is the simplest one that you can get, you just, of course, turn it on, and then you will find, in most of them, this is on top of the division sign. You will see something like NCR. That's what I have over here. This is combinations and R. So let's say that I want to calculate that value. So what do I do? In this particular calculator, you do 5. To access that thing on top of the division sign, you have to do shift division sign. You will see a C there. Okay, I cannot see, but trust me, there's a C over there. So 5C3. Press enter and you have 10. Okay, as simple as that. So all of this to tell you what? To tell you that there is a way for you to calculate all these values over here, which are all these values over here, which are what? Don't forget what is the original purpose of this, is to find the coefficients of each term on a binomial expansion. Okay? Again, you can get, using your calculator, all the coefficients. So now you know everything. Okay? So if you want to expand x plus y to the power of n, what do? You do the combination n r, and r is going to change from the first term until the last one. The n is going to be whatever your power is over there, and then you are going to change. It starts with combination n0, then n1 for the second term, n2 for the third term, n3 and 4, etc., and eventually n minus 2, n minus 1, and the last term is always n combinations n. Again, what is happening to the power of x? It has the value n in the first term, in the second term n minus 1, in the third term n minus 2, and continues until you have x to the power of 1 and x to the power of 0. What is happening to the power of y? It starts with 0, then it's 1, then it's 2, blah, 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 until it's n minus 2, n minus 1, n. So here you have the pattern for x, for y, and a way to calculate the coefficients. Until today, you only knew how to expand x plus y to the power of 2. Now you know how to expand x plus y to the power of whatever whole number that you have there. Okay? This is the main idea behind what this means. You now know how to use this formula. Okay? Pay attention that in the MF19, instead of x and y, you have a and b. Okay? And they have a simplified version. I just wrote this down for you to see the pattern, but actually combinations n, 0, whatever they are just 1, and y to the power of 0 is always 1. So they just put x to the power of n as the first term, and instead of x they use a, so it's a to the power of n. For the same reason, the last term, I wrote it over here, but combinations n, whatever n is always going to be 1. X to the power of 0 is always going to be 1, so the last term is always going to be y to the power of n, or using the notation that they have in the MF19, b to the power of n. So this and this is the same. The one that you have in the MF19 is a simplified version, but it's important that you know where it comes from, and that was the purpose of all of this explanation. If x is 1, then it simplifies even further. You don't have to worry about x. That's always going to be 1. You just focus on y. All right? So In this case, I'm not going to explain any further. If you want, do it yourself. And the formula that you have in the MF 19, instead of using combinations, it uses this formula over here. Okay, that's why you have it the way it is shown over here. It's not common for you to have this questions involving this, but it may happen. You need to know where this comes from. And the role now is your role now is, now that you know where all of this comes from, is to apply it to questions. Again, follow the structure that you have in my course. Start simple. Start building your trust about this, solving simpler questions, get more and more complex, and eventually reach the exam style questions and the exam questions. And you are going to see that the structure of all of this is all the same.